Hello everyone. We're going to go ahead and get the notes taken care of, finishing up our introduction to SohCahToa. What you're going to get here in these notes is the information needed to solve what are called inverse functions. So let's go ahead and get that taken care of. If you need to, you can pause the video so everyone can finish titling that. I'm going to go ahead and move on. So what we have from the past couple classes is all revolving around solving right triangles. Okay, we initially went to the Pythagorean theorem, which is what you use if you've got two sides and you know there's a right angle in there. If we have that, we can simply go a squared plus b squared equals c squared, where c is the longest side, which is called the hypotenuse. Solve for the missing one, and we're done. Then we got some shortcuts where we didn't have to use Pythagorean theorem. Okay, if we had one side only, you only need one here, one side, and you also know that the other two angles are exactly 30 and exactly 60, or you know that the other two angles are exactly 45 and 45. All you have to have, again, is one side of the triangle, and you can get the other side by simply using our shortcuts. Short leg to long leg times root 3. Short leg to hypotenuse times 2. Over here, if your leg is 11, that means both legs would be 11. To get to the hypotenuse from either one, we multiply by a root 2. Now, once you have one of the sides, you could use Pythagorean theorem to go and get the third side. Okay, so once you know two sides, you can use Pythagorean theorem to get the third side, but you don't have to. If you've got the shortcut, why not continue on? Then last class we added in our newest one where we still have a right triangle, but again, just like with our special right triangles above, we only have one side length, which means we can't use Pythagorean theorem because we would have two unknowns. But then we have a new problem that comes in here, and the angle that we've been given is not a 30 or a 60 or exactly 45. In this example, I put a 61 degrees. We can get our missing angle by subtracting the 2 that we've been given from 180, because every triangle has to have 3 angles that add up to 180 degrees exactly, and that would give us 29 degrees for our missing angle. So that's no big deal, but then getting the other sides, we have to use trig. Okay, Pythagorean theorem wouldn't work again because we would have, if we did a squared plus b squared equals c squared, okay, we would have two variables, two unknowns. Okay, so let's do of what we saw last class. I'm going to do one example. If you guys are good with that, you can fast forward, but I think there are people who probably have questions over some of these things still. So I'm going to start off by taking this problem, and I'm going to label our vertices A, B, and C. No specific order there, just need to have capital letters. Then we had our rule that to name the sides with a single lowercase letter, you name the opposite side with the corresponding lowercase version, which makes me want to go right here. I'm going to get rid of that X just so it's not confusing. I don't need two separate variables for the same letter or the same side. There we go. And then our third one here was A. Okay, so what we have on this problem is, again, like an old one. We have one side we know it's a right triangle, and we have one angle. That angle is not a 30, 60, or 45, so we can't use our shortcuts. We only have one side on our triangle, so we can't use Pythagorean theorem, but our job is still to find all of our missing information. Just like last time, I'm going to make a box over here. To put all the final answers, because again, the work can get kind of messy. This will help us keep track of everything. Okay, so we've been given that side A is 6.6. We've been given angle B is 90 degrees, and we do know that angle A is 17 degrees. So with some quick subtraction, 180 minus 17 minus 90 gives us 73 degrees. Double checking that, yep. For angle C. And if you want, we can write that in there really small. So we've got one out of our 3 missing things taken care of. Let's go ahead and find the next one. In order to find these side lengths, we're going to need to use SohCahToa. So I'm just going to write our acronym up there. Okay, and remember that it's broken into 3 chunks where the first letter of each of our 3-letter groups has the equal sign behind it, and then the other ones are split up. Try that again. As our fractions. Okay, so first thing we need to do is pick our reference angle. You can pick whichever one you would like, as long as it's one of the acute angles. My suggestion is always pick what's given with the question, just in case you had a little mistake on that 73 degrees. So I'm going to go ahead and put a star here at angle A, okay, to let us know, okay, our reference angle is angle A. Okay, from that, our second step is to label the sides coming from angle A, hypotenuse, adjacent, and opposite. So hypotenuse is always across from the right angle. So that's going to be this side lowercase b, which is one of the ones that we are looking for. The next one to check for is the opposite, which is going to be opposite the triangle from it. So side little a. Oops, I don't know why I just wrote it, I think. Well, I will have to use the eraser tool. There we go. Thought there was an undo. Okay, so that's going to be the opposite, which leaves angle C as the adjacent side. Okay, with that, we're all set up and ready to go. So we can pick one of the 2 sides, whichever one we feel like solving for first. I'm going to go ahead and let's use orange. Solve for angle or side B first. Okay. Now, in order to set up our equation, we're going to have to pick which of our 3 groups we want to use. And to pick that, we need to know what side we have and which side we want. So we have the opposite side, and if we're looking for side B, that's the hypotenuse that we want. So of our 3 trig functions, the one that we will want to use is the one with the O and the H. So sine. With that, we now go down and set up our equation. So sine of our reference angle, which is 17 degrees, is equal to the opposite, 6.6, over the hypotenuse, which was letter B. Okay, now it's just jumping back to a little bit of algebra. Now we saw one example, or it was posted online. Okay, A lot of you get stuck when you see a variable in the bottom and you think that you just solve it the same way. Remember that you cannot get a variable alone in the bottom, like you won't be done working on the problem. So our number one goal is to get that out of the bottom. So just like we get rid of any other number that's in the bottom, we can multiply both sides by that particular number. Those two factors of b would simplify to a factor of 1, and 1 times 6.6 gives us 6.6. Over here we have b times sine of 17 degrees. Okay. Well, sine of 17 degrees, it may look ugly, but it is just a single number. If you were to type that in your calculator, it's a single number, ugly number, but single. That's a number times our variable b. So in order to get b alone, we have to divide by that number. On this side, these simplify to a factor of 1. 1 times b is b. And on the other side, we'd have 6.6 divided by the sine of 17. Let me type that in here. 6.6 divided by... Oh, my calculator works differently. Some of you might have calculators that when you push the sine button, it automatically pops up with the number. You can't type it in the way it's written. Okay, with those, you have to type in the degrees. So on mine, I would do 17. Then I'd push sine, and then equals. And I get 22.57. I hope that's right. It's late and I'm tired, so double check with the calculators in there. If everyone gets something different, you're probably right, and I'm just tired. But so far it's looking alright because my short side right there, the one across from our smallest angle, 17 degrees, is 6.6, so I know that it's at least going to have to be bigger than that. Let's see what we get on the other one and then we can compare. I'm doing that on my phone, so yeah. Okay, let's go ahead and take care of side C. Again, I suggest using the information that you have been given first, just in case you have a mistake. So I'm not going to use that 22.6 to find side C. I'm just going to stick with what I've got given to me. So I'm going to go ahead and use that opposite side again. But then side C is adjacent, so the trig function that uses opposite and adjacent is tangent. So setting this up, we take the trig function of our reference angle. Notice I didn't change my labels. That means I'm still coming from angle A as the reference angle, is equal to the opposite, 6.6, divided by the adjacent, which is side C. That should look familiar as far as what we're going to do to solve. It's exactly the same as what we did over here. So pretty much the only difference is we're going to push the tangent button. I'll write it out for people who would like to see it. These simplified to a factor of 1, leaving us just 6.6. And after that, we got rid of this ugly number here. What we do to one side, we have to do to the other. Simplifies to a factor of 1. C is equal to, now again I'll use my phone calculator to get this. You guys check and decide what it is in class. 17 and tangent. And I get 21.6. Okay, now how can I judge whether or not that's reasonable? Remember that we said the smallest angles across from smallest side, biggest angles across from biggest side, and so forth. You can also kind of estimate based on your angles. If we know this angle, our reference angle up here, is only 17 degrees, and 73 and 90 are a lot bigger than that, the sides across from 73 and 90 are going to be a lot bigger than the side across from 17 degrees, which is what we have. 73 and 90 also aren't very far from each other, so this looks reasonable to me. I'm going to say I'm pretty confident that's the correct answer, despite typing it in my phone calculator. Okay, so there's a review of what we did last class. Now let's go ahead and talk about what we're going to get for this class. Our last trick that we need in order to be able to do all the other problems on For the problems that we skipped over on the worksheet, the difference between them is that on the last one, like we just saw, we knew two angles. Those angles were a 90-degree angle and then some other angle. And we were given one side. On today's problem, we only know the 90-degree angle. We only have one side, one angle, but we have two sides. So, how are we going to do this? Well, hopefully when you look at this, I'm hoping that this missing side stands out because, again, we have two sides. And anytime we have two sides, and it's a right triangle, I'm hoping you're thinking it in your head. Yes, Pythagorean theorem. Okay, so on these problems, you'll do Pythagorean theorem to get your side lengths. Where the trick is going to come in is finding these missing angles. Okay. To get these missing angles, what we're going to have to use are what are called inverse functions. And you'll see why when we set it up. But basically, in order to get rid of a function, you have to use its inverse function. Just like in order to get rid of addition, we have to do its inverse operation. To get rid of multiplication, we do its inverse operation. To get rid of squaring, we do its inverse operation. Okay, sine has an inverse operation, and you may have noticed on your calculator it's there. I'm pretty sure you have your button that says sine, and then up in blue above it, you see sine with a little exponent of -1. That is the inverse sine function. This is the function that when you do it to a sine function, they simplify out. I don't want to say cancel out. They kind of do. I'm trying to not say that word though. Okay, so this works. We've got a triangle here. I'll give you actually just pause the video so people can copy it. I'll go ahead and label our sides and angles. So the angles are the capital letters A, B, and C. The sides are lowercase and they match the one opposite it. So A coming across over here, that means we have a little a is opposite big A, little c is opposite big C, and little b is opposite big B. Don't worry about putting that X because we're going to solve the triangle, so we're going to be looking for all of them. I'm just going to get rid of that so we don't have a million different variables. We'll just call it angle A. And then I'll set up my answer section up here. So measure of angle A equals measure of angle B equals measure of angle C equals, come on pen, and then little a equals, little b equals, and little c equals. Okay, so on this problem we know that angle C is our 90-degree angle, side A is 12, and side C is 17. Let's go ahead and get side B taken care of. And I think I'll be nice and let you guys just round to the 10th place on this since we were doing that with the trig functions as well. So don't worry about simplifying your square roots on this assignment. I'll let you get by without that. Excuse me. So let's try to keep my work organized. Side B, using a quick Pythagorean theorem, we see that C is our hypotenuse because it's across from the 90-degree angle. So that one will have to be the loner on the side of the equal sign. Our other two will go on their own side. We get 144 plus b squared equals, I think that's 289. Let me get my calculator. 17 times 17. Yep, 289. Subtracting 144 from both sides, we get 145 on this side. And then to get rid of our square, we'll square root both sides. I know 12 squared is 144, so 145 is going to be pretty close to that. Hey, look at that, 12.04. We're going to round to the tenths like we've been doing on all the others. So this one will actually turn out to be 12.04. Rounding, we get 12. Now some of you might be like, ooh, ooh, ooh. 12, 12, 45, 45, 90 triangle? Unfortunately, that's not actually the case because this isn't really 12. It's actually 12.04. But that does give us an indication that these angles are going to be pretty close to being one being 45 and one being 40, the other one being 45. So it might be like a 44 and a 46 or a 43 and a 47. Okay, just because it is so close to being a 45, 45, 90 triangle. Okay, let's get to our new stuff now. We need to find those angles. To do this, we're going to need our SohCahToa, so I'm going to write that up here. Our three groups, just sounding it out. Remind us that it's an equal sign after the first letter, division or fraction between the second two. Okay, to solve for each angle, the angle you're solving for needs to be the reference angle. So if I choose to solve for angle A first, angle A will have to be the reference angle. Coming from angle A, we already know the hypotenuse is C. The opposite side from angle A is little a. That means little b will have to be the adjacent. ADJ, not ABJ. Okay. With that, I'm going to put, oops, not side, angle A is what we're looking for. So you got it in sections here. Okay, with that, we know we want to find angle A, and out of the other three sides, we have all three, which means we have the freedom to use whichever trig function we want. The suggestion, again, is to use what's been given to you. So I'm going to suggest using the 12 and the 17 that have been given, just in case we have a mistake on our side B that we just found. So if we use the 12 and the 17 that were given, that would mean we have to use sine to find angle A. We set up our equation just like we did the other day, where it's sine of the reference angle. Well, in this case, we don't know what it is, so we're going to put the variable A is equal to opposite, which is 12, over the hypotenuse, which is 17. Just like we had the other day, our goal is to get our variable alone, right? Which is A. Now, thinking back to Algebra 1, when we had like x plus 3 equals 12, did we say, okay, well, there's an x and a plus right next to that 3, so I'm going to divide out an x and a plus sign? No, that doesn't make any sense. You can't divide out operations, right? Instead, what we did is we said, okay, well, we have an x plus 3. What's the inverse operation for addition? Oh, subtraction. And I don't know why I got rid of the x plus. It would have been the 3, but you get the idea. We have to do the inverse operation to get rid of the plus sign as well as the 3. Okay? The same idea happens here. Okay, in order to get rid of just the operation, the function sine, okay, we can't just divide out a sine of no angle. We can divide out, like we had on the last one, sine of 17, that is a number, but just the sine, that's like dividing out a plus sign because it's next to something. In order to get rid of a function or an operation, you have to do its inverse. Okay, so the inverse here, and I'm going to erase that box around it because it's kind of messy. The inverse function for sine is to do the sine inverse. So I'm going to recopy what we have just so I have a little bit more room. We have sine of A equals 12 over 17. In order to get rid of our sine function, we are going to do the inverse sine, and what we do to one side we have to do to the other. What happens here is that's like a plus sign and a minus sign. Those operations simplify out, leaving, voila, our letter all alone. On this side, it's ready to go in the calculator. You would type in the inverse sine, which is blue above the button, so you'd have to hit second and then the sine button, and then 12 divided by 17. Now let's see if I can figure out how to do that on my phone here. Okay, 12 divided by 17 equals, and then I have to hit second sine. I get 44.9 degrees if I round to the tenths. Hey, that kind of goes right with our estimate, right? 44.9 degrees. It's pretty close to 45 degrees. This was really close to a 45, 90. Okay, once we have that, you have two options now. I think I know which option you all will pick, but if you wanted to, you could rearrange your reference angle, because in order to solve for an angle with this, it has to be the reference angle. So reorganize it so B is the reference angle and do trig. Or some of you may have already figured out the shorter way, which is remembering that all three angles have to add up to 180. So you could skip the trig to find the second angle and just go 180 minus the 90 degrees minus the 44.9 degrees, which gives us 45.1 degrees for angle B. And what was it? 44.9. And there are our final answers. Okay, I have one more, I think. Okay, with this one you should probably be doing just fine when we get done here. Again, I'm going to get rid of the x so we don't have a million variables out here. I'll name the vertices and set up the answer box. A, B, C, which means side opposite A is little a right there. Opposite C is little c. Opposite B is little b. Up here in the corner, we'll have our answer box. Measure of angle A equals, measure of angle B equals, measure of angle C equals. Little a is 32, little b is 40. Nope, not little b. That's, whatever, it's going to be out of order. We'll see. Little b is what we need to find. Oh, and big B is 90 degrees. Okay, so just like the last time, we have 2 out of the 3 sides of a right triangle, which means we can do a quick Pythagorean theorem, okay, to solve for our missing side, which happens to be the hypotenuse. So to find side B, we would take 32 squared, oops, not degrees, squared, now that looks like 20. 32 squared plus 40 squared is equal to b squared. And I'm just going to do that in the calculator and get the answer. 32 squared plus 40 squared is 1600. Okay, altogether 2624. And then we're going to square root. So we get B is equal to approximately 51.2. Okay, just making sure my stuff's right. Okay, so that gives us our missing side here, 51.2. Now we go to our angles. We can pick whichever one we want. I'll just go with A again because I feel like it. So A, again, we have to pick our reference angle. If we're going to solve for that angle, it's got to be the one that we're picking. So if we're going to solve for A first, A has to be the reference angle. So from that reference angle, we have the hypotenuse labeled already. Opposite would be little a, which means C is the adjacent. Put our SohCahToa up here. Got writing a little bit sloppy. Let me try that again. Okay. S equals C equals T equals slash slash slash. Okay. So if angle A is what we're going to be looking for, we're going to need two sides of the triangle in order to set up our trig function. Again, my suggestion, use the ones that have been given, which are opposite and adjacent. Therefore, our equation we're going to set up is tangent. So setting it up like we've done all the other ones. Tangent of our angle, which is just the variable A, is equal to the opposite, so 32, over the adjacent, which is 40. Now, I have A, I want to get a lone, and I want to get rid of a function. It's not tangent of some number. If it were tangent of a number times A, we could divide out that tangent of the number. But this is just a tangent. It's like a plus sign, a lone. So we got to do the inverse operation to get rid of it. What we do to one side, we have to do to the other. This side, those simplify, leaving just A. That's like x plus 3 minus 3. Leaves you just with x. And then on the other side, we have, let me type it in, inverse tangent of 32 divided by 40. That second tangent. And we get 38.7 if we round it correctly for angle A. Now again, you're welcome to do trig to find angle C. You would just have to remember to change your reference angle, which means this side would no longer be adjacent. It would be opposite from the reference angle C. Hypotenuse stays the same. Our opposite would become adjacent. And then you could set it up there. On that one it would be, if you wanted to know, tangent of angle C is equal to 40 over 32. So same process of solving and typing in, we would essentially just have the tangent of inverse of 40 over 32. And if you want to do your subtracting from 180, because our other option is to go 180 minus 90 minus our 38.7, I'm going to do it both ways so we can just see that it works. 40 divided by 32 is equal to that. Then we're going to inverse tangent it. And when I do my inverse tangent, my calculator comes out with 51.3, and I wrote a 31. I'm at 51.3 degrees, which, holy cow, is the same thing I got right here. Yay. Okay, so with that last short trick, you now have all the information you need in order to solve right triangles. You also have all the tools you need in order to do our PBL, which we will be doing either next class or the following one. So as you're working on this, be thinking to yourself, how might this apply to finding the height of some building that, or height that's inconvenient to go and put a measuring tape next to. Closing, if you wanted to write these down, you can pause it, but the main idea is if you're looking for a side length, you're going to use the original function. If you need to find a missing angle, that's when the inverse functions come in. And my exponents here came down. That's supposed to be a little exponent. It's not sine minus 1, cosine minus 1. There, that's what it's supposed to be. Okay. So with that, your assignment is to finish that Solving Right Triangles worksheet. I was nice and I made it so you guys only go through number 14. Don't make me regret that. Okay. If I'm seeing that we're not understanding it or there's a bunch of incomplete ones, then we'll go ahead and add all the way on to 20. Okay, I'm not taking this incomplete, so if you have any of it that's not done, you're not going to get full credit for it, which would be so sad if you've done most of it. Okay, the most you could get is late credit. It needs to be completed by next class. Okay, so with that, you're awesome. Enjoy your work time. Use it well. Get her done. We'll see you next class.